The next paper presentation is from Mr. Chanti. The title of the paper is RGF Bot, a novel feature selection method to identify malicious bot accounts on social networking sites using machine learning. Over to you, Chanti.
Sir, am I audible, sir?
Yes, please continue.
Yes. So can you see the? Am I?
It's visible. Please
Yes, sir.
continue.
Sir. Thank you, sir.
Can you put it in the
Yes, sir. Yes, sir.
quickly
Yes, sir.
show mode F5?
Is that okay, sir?
Yes, please continue. You have 8 minutes, please.
Okay, sir. Good afternoon, everyone. Myself, Chanti, research scholar from Pondicherry University. The title of my presentation is RGF Bot, a novel feature selection method to identify malicious bot accounts on social networking sites using machine learning. So the agenda of my presentation is as follows. So in this paper, what we are focusing on is like to detect malicious bot accounts on social networking sites. We can use machine learning as a best solution for detecting. Like machine learning, there are features for detecting bot accounts. There are existing feature selection methods which can be used to reduce the number of features to an optimal set of features, yet maintaining the same or better accuracy. So what we are going to focus on this proposed work is like whether the optimal set of features which we have been identified from the existing feature selection methods can still be reduced to a minimal set of features, yet maintaining the same or improved accuracy. So as an introduction, we are focusing on what is a bot. Bot accounts are the computer programs used to automate actions on social media platforms such as creating content, liking, following, and retweeting. The bot accounts can also be used to spread phishing attacks on social networking sites by sharing the malicious links through the bot accounts to the internet users. So this is an example. So why detecting of a bot account is important? So identifying and stopping bot accounts will help the internet users safeguarding their credentials. Bot accounts can facilitate the discrimination of phishing scams, fake news, and malware detection. Detecting helps protect users' privacy and helps in protecting their identity to be stolen by the attacker. How to detect malicious bot accounts on social networking sites? Uh, in this article, we proposed a novel feature selection method called recursive grouping of features, which will reduce the number of features to a minimal set of features for better detection of malicious bot accounts. So RGF is effective in identifying malicious bot accounts on social networking sites with minimal features. So there are some existing works focused on phishing bot account detection. Most of the machine learning based approaches which is used for bot account detection can be categorized into two types based on the existing literature. There are methods which in which they don't use any feature selection methods. They just apply train the model with the available bot detection data set and use exist classification algorithms, and they produce the results. There are some other techniques where they use the feature selection methods like PCA or variance method, random forest inference methods to rank the features, and by eliminating the least performing features, they're improving the accuracy. So these are some existing works. What are the type of whether they use any feature selection methods or not? What type of data set they used, what type of machine learning algorithm they used for training and achieving accuracy, the performance in terms of accuracy, precision, recall. So what are the key findings in those works has been listed here. So in data collection, so for this proposed work, we have collected two standard data sets. The first standard data set is collected from Kaggle. So the data set contains 1585 records and 29 features. The second data set is collected from bot repository, so which contains 30 features. So these are the list of features from the data set one. the 29 features, and from data set 2, 30 features. So before going to the proposed model, what we did is like we collected all the features from data set 1 and 2, and we applied the existing feature selection methods like variance score method, a random forest input, and gradient boost methods, and we ranked the features with a statistical score. So based on the rank, we just sorted the features, and the features with the rank less than 0.001 has been eliminated from the feature list. That's how we got the optimal feature sets. So since we applied a 3 feature selection method, so we got 3 optimal feature sets. So once we identifying the optimal feature sets, so then we are going to find the best classification algorithm. So in that, for that, we just applied all the classification algorithms like decision trees, KNN, logistic regression, Navy Bayes, support vector mission, random forest, on all the 3 features ranked feature sets. Based on the performance, we found that decision trees performed better on the selected data sets. So earlier we identified the optimal feature sets from 3 different feature selection methods. From the 3, we had to find the best performing feature selection method. So when I applied on the 2 data sets, we found that variance ranked optimal feature sets performed better on data set 1, whereas on second data set, the random forest important ranked optimal feature set performed better. So we also used gradient boost important ranked feature set, but the problem with this is like the number of features has been reduced to very minimal, and it is like fluctuating with when applying on different data sets. So it is not stable, and there is more chance that it would be very data set specific. So this is the overall architecture. Like so initially we collected the data set and we applied the existing feature selection method. By applying variance score method, we ranked the features, removed the features with less than rank 0.001, and sorted the features in descending order. So same applied for random forest ranked method and GBA method. So we'll get 3 optimal feature sets. Among this, we just take one by one and we apply in the process, and we'll find the apply all classification algorithms, and we calculate the accuracy, precision, recall, all performance metrics, and we'll find among these 3 which ranked feature set obtained will be the better. So these are the performance. So we selected all the feature selection methods and applied all the classification algorithms. These are the initial features, like total features. After applying the feature selection methods, how many features we obtained, the optimal features. These are the performance metrics. So we calculated. So this is for the data set 1, and this is for data set 2. As I said in the previous slide, so for the data set 1, we found VS ranked feature set better. For our data set 2, we get RFI based optimal feature sets performed better with optimal features. So next we will go for the proposed model. So earlier we took all the features and we applied existing feature selection methods, whereas in proposed model we are considering all the features, and we apply the proposed RGF method to find the minimal feature sets. So how we are going to do that? Initially we creating a group capital G with the ranked feature sets, and we divide that features. We already ranked it in descending order, and we'll divide that group capital G into 2 groups. The first 70% of top ranked features will be in group 1, and the remaining 30% of features will be in group 2. A machine learning model is built on group 1 to calculate the accuracy by using the capital G. C, it is the decision trees. The feature exclusion method is executed when the G1 accuracy is lower than G accuracy minus 1%. So here the conditions which we considered is like the initial accuracy with all the features, and the difference must be less than 1%. So the feature inclusion method will be executed when it is greater than the G1 accuracy minus 1%. So when the initially constructed group with all features and the divided group with G1, we'll compare the accuracies. If the G1 accuracy is actually less than the G accuracy, then what we'll do is like we will add features from the second group. So this process will be repeated until we'll get that equal or higher accuracy.
Chanti, you have 2 minutes.
Okay. So here you can see the proposed model. So initially we created a group capital G. We split the group into 70% and 30%. We built a machine learning model. We calculated the accuracy. We'll check the condition. If the condition is satisfied, we'll go for feature exclusion method, or else we will go for feature inclusion method, and a minimal feature set is created. So later what we'll do, we'll count the number of features in the group capital G, and we'll compare whether that created group is equal to the G1 count. If it is equal, then we can terminate the process, or else we can create a new group and we'll follow the same process again. This process will stop until no new minimal feature set is created. So what is that feature exclusion method will do? We'll remove one by one feature selector, the least performing features from the group, and every time removing one feature, it will check for the accuracy and check the conditions. If the condition is satisfied, it will remove one more feature, or else it will end the process. Same as in inclusion process, here one by one features will be included from the next group. So the RGF process generated the first minimal feature set after completion of iteration, which I explained just now. So for the experimentation process, we considered 2 data sets, and we applied the proposed method on 2 data sets with these ranked feature sets. And we these are the results you can see. On first data set, I applied all features, and I create for the first data set, I got 3 minimal feature sets. For second data set also, I got 3 minimal feature sets. The first minimal feature set itself is enough to get the same accuracy as all the features I got. So in the case of data set 1, I got same accuracy, but in the case of data set 2, I got an increased accuracy. So like earlier with all features, it is like 99.78%. With the minimal feature set 1 itself, I'm getting 99.95% accuracy. So you can see here. So the accuracy with all features and the accuracy with the minimal feature set 1. So this is for data set 1, this is for data set 2. The core findings. The VS ranked feature set performed better on both Kaggle and bot repository dataset, achieving a higher accuracy for the corresponding minimal feature sets. So Decision trees was identified as the best classification algorithm based on the results. Specifically, the minimal feature set 1 with the 12 features achieved 99.74% accuracy on Kaggle dataset, and the minimal feature set 1 with 11 features achieved 99.9% accuracy on bot repository dataset when compared to overall features. So since RGF is a generic method, it can be applied to any classification based data set for obtaining a minimal feature set. In this paper, we proposed a novel feature selection method to reduce the number of features to a minimal set of features, yet achieving the same or higher accuracy. So as you see in data set 1, we are getting 90 here. So 99.7% on data set 1 and 99.95% on data set 2. So on data set 1 with only 12 features, I'm getting 99.74% accuracy. On data set 2, earlier it is 30 features, but with 11 features itself, I'm getting 99.95% of accuracy. That's it. These are some references.